Hello everyone. Last class we tried to figure out the velocity of a given position time graph. So we can calculate velocity average, the average velocity by using this formula x2 minus x1 upon t2 minus t1. To find out the average velocity for a given position time curve, suppose this is the position versus time graph. To find the velocity at a given point, so if we consider these 2 points, so at these 2 points we can get that average velocity. But to find the instantaneous velocity at that instant, at that given particular time, so to find the instantaneous velocity, if you find the instantaneous velocity, so this formula it won't work because we are having the time dependent factor a single term. So time at that location, it gives an exact point, exact time. So that if you can understand by using this graph, suppose this is my position versus time graph. So let this green one take this graph of any function. So here the function is f of x equal to x square, just like position versus time graph. Here I am talking in terms of mathematical language. Suppose I want to find out the slope. The slope of a given curve gives the velocity. So here the difference in the y component upon difference in the x component, delta y upon delta x, here I can get the slope 1.87. So here the slope means to me velocity, because the slope of velocity time graph gives, the slope of displacement time graph gives velocity. Suppose if I bring these 2 points close each other, so I bring these 2 points close each other, still they are having certain difference. Suppose if you can take the zoom in of this particular location, so if I bring close to these points one upon other, now if I bring these 2 points as a single point, now here we can see what's the value upon delta y upon delta x. Here there is no difference, but I would like to find the slope at that location, so that gives to me the instantaneous velocity. So the formula what we are using, that y2 minus x2 minus x1 upon t2 minus t1. So at here this formula fails. So here we need to find with the different mathematics. So that's known as limits. Particularly that comes under differentiation. So to calculate that location slope, here we are using dy upon dx. So that gives that limit delta x tends to 0. So the difference in the x variables is 0. So the ratio of delta y by delta x, if you change our mathematics at here, so here I can able to find the slope at that point 0.600. So this gives to me the instantaneous velocity. So these values we will find by doing differentiation of the given function. Suppose if I know what is this function, so to this function if I do the differentiation, so then we can get the slope of that particular location. So today I would like to give certain differentiation formulas, how to solve these differentiation formulas. So we will learn certain differentiation formulas and we will apply on this course. So first we can represent differentiation as in d by dx of constant might be any number, so its constant equal to 0. Example, so d by dx of, you take a number 10 is a constant, its a differentiation cannot be 2 because it's a function, sorry, it's a constant, it's a number. Second formula, d by dx of some constant times a function f of x, which equal to, so we do not do differentiation to constant, so it will be go out of differentiation. So d by dx of, so k of, so d by dx of f of x. So in a simple terms we also can represent that k times f dash x. So here f dash x is nothing but d by dx of f of x. So in short form we will write that differentiation in terms of f dash x. Suppose if you can take an example, now d by dx of 5x. So this we can do like this, 5 times d by dx of x. Now here we have to do the differentiation for this d by dx of x. So its value equal to 1, so the end result will becomes 5. So this is how we can do that. First I will write the formulas and later we can discuss certain examples. Suppose d by dx of two functions, f of x plus or minus g of x. So these two are the two functions. So we can do the d by dx of f of x plus or minus d by dx of g of x. Or in another form also you can write d by dx of x, you can write that f dash x plus or minus g dash x. So that is one more formula. Now very important formula, product rule, d by dx of, we can take that u times v. Here the u, v are two functions, so these are the two different functions. So this we can write that as first function u times, we can write the differentiation of the second function dv by dx plus second function v times differentiation of first function du by dx. So that we can say in terms of product rule. So similarly one more, d by dx of u by v. So here u and v are the again two functions. We can write that as v du by dx minus u dv by dx upon v square. So here again u and v are two different functions. So apart of that, very regular functions, very regular relations what we can use. So d by dx of x power n, which equal to n into x power n minus 1. Differentiation for as an x power n. So I would like to write some trigonometric functions. D by dx of sin x, which equal to cos x, and d by dx of cos x, which equal to minus sin x, and d by dx of tan x, which equal to sec square x, and d by dx of cot x is equal to minus cosec square x, and d by dx of secant x is equal to secant x tan x, and d by dx of last one cosec x is equal to minus cosec x cot x. So these are the certain trigonometric functions: sin x, d by dx of sin x, cos x, and cos x minus sin x, tan x is sec square x, and d by dx of cot x minus cosecant square x, and d by dx of secant x is equal to secant x tan x, and d by dx of cosecant x equal to minus cosecant x cot x. And two more formulas which we frequently use, so that is d by dx of e power of x. So e power of x differentiation, same e power of x, and d by dx of a power x, so it's equal to a power x log a. And last formula I can give d by dx of ln x. Ln means natural logarithm, ln x which equal to 1 over x. So these are some of the differentiation formulas we may use in this course of physics at different locations, at different chapters we can use. But altogether these are the certain important formulas we will face. So these formulas you learn properly. When the right situation comes, we will apply these formulas to solve certain problems so that we can understand those carefully. So here u and v are two functions. There are two functions, or otherwise if you can take that u equal to f of x, one function, and v is also equal to g of x, just like above how I taken that f of x and g of x are the two different functions. So the product rule and division rule are important, and x power n, so this rule we use very frequently, d by dx of x power n which equal to n into x power n minus 1. So I would like to solve certain problems so that we can understand about this differentiation, how we apply